Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog. We're going to talk about derivatives of the natural logarithm today. And one thing to remember about logarithms, the domain has to be greater than 0. So keep that in mind. X values here, whatever's inside the logarithm, has to be greater than 0. Now, what's the derivative of the natural log of x? The derivative is 1 over x. That's our formula. But let's say I was taking the derivative of the natural log of a function u. Let's say u is a function of x. Well, it would still be 1 over u, but you'd have to multiply by the derivative of the function, u prime. So the derivative of the natural log of u is u prime over u, given that the function doesn't equal 0 or the function is less than 0. So how do I take the derivative of the natural log of 2x? Well, it's pretty easy. You put the derivative of the function on the top, you put the function itself on the bottom, and in this case, that reduces to 1 over x. Wait a minute. What if I took the derivative of the natural log of 3x? Well, that would be the derivative of the function, which is 3, over the function itself, 3x, that also reduces to 1 over x. So let's create a formula here. What's the derivative of the natural log of any number times x? It looks like the derivative of that would be a over a times x. That would still reduce to 1 over x. So it doesn't matter what number I multiply times x. Inside the logarithm, derivative is still going to be 1 over x. And if you want to, you can pause the video right now and write that formula down if that's going to help you. But I'm going to erase this because I want to show you a different way to do this problem. And the other way I'm going to do this problem is to think, hey, why don't I expand that logarithm? In other words, before I take the derivative, let's expand this logarithm. This is multiplication. So I can put the natural log of 2 plus the natural log of x. And then my derivative would be, well, what's the derivative of the natural log of 2? Well, that's a constant because there's no x. The derivative would be 0. And the derivative of the natural log of x would be 1 over x. And look at that. I still get 1 over x. So expanding the logarithm is still going to give you the same derivative. Or you can just take the derivative the way it's written. This next problem over here, well, I'm going to have to just take the derivative the way it's written because I can't expand this. The derivative of the function inside would be 2x. The function itself is x squared plus 1. There is the derivative of that logarithm. As we go down the page here, you're going to see where I'm going to throw some different formulas at you. This is a product rule. How do you do a product rule? Well, we take the derivative of the first function, which is 1, times the second function, plus the first function times the derivative of the second function. So my derivative here would be the natural log of x plus 1. So everything you would have learned up to this point, you can use on logarithm problems now. You can use power rules. You can use product rules. Here's a chain rule. This next problem involves a chain rule because I've got a logarithm raised to a power. How do you take the derivative of something to the third? Well, we're going to bring the 3 out front, and that something is now going to be raised to the second power. Well, how do you do a chain rule? Chain rule, once you've done that first function, you take the derivative and you multiply it by it on the outside. The derivative of the inside would be 1 over x. So this would reduce to 3, and the natural log of x would be squared, and this would be all over x. There would be your derivative using a chain rule. Okay. Now this next one appears to be a chain rule as well, because I've got a x plus 1 inside a radical, which is inside a logarithm. Now, ladies and gentlemen, I tell you what, this is something I insist on with my students. You're going to make your life a lot easier if you take that logarithm and you expand it. If I expand this logarithm, I can bring that 1/2 out front, and this would be the natural log of x plus 1. And this makes it a much simpler derivative because that 1/2 is just a constant. And you would take a constant times the derivative of the natural log, which would be the derivative of the inside function over the inside function. So this would come out to be 1 over 2x plus 2. And that seems a lot easier than actually trying to do the derivative of this function, where you take the derivative of the inside function, which is 1/2, x plus 1 to the negative 1/2. And then you'd have to divide by the function itself, which would be x plus 1 to the 1/2. The 1/2 there would put a 2 on the bottom. You would have x plus 1 to the 1/2 from this, and then there'd be another x plus 1 to the 1/2 from this, and those would multiply to give me this. But it seems like a lot more work. It still works. It's just you're going to do a lot more work. It's going to be a little more complicated. So when you see a problem like this, you're thinking, oh my goodness, x times the parentheses, that's a product rule. I got power rules. I got a quotient rule because there's division. I got chain rules on the bottom and the top. I don't want to do this. So what I'm going to do is I'm going to expand this logarithm first. I'm not going to take the derivative yet. This would expand into the natural log of x multiplied, so plus the natural log of x squared plus 1, I can bring the 2 out front, minus the natural log of 2x cubed minus 1. That's a square root, so I can bring a 1/2 out front. I've expanded my logarithm, which is going to make my derivative a lot easier. What is the derivative of the natural log of x? Well, it's 1 over x. The next term, I'd have 2 times the derivative of this, which would be 2x over x squared plus 1. And then it would be minus 1/2 times the derivative of the logarithm, which would be, take the derivative of the inside, which would be 6x squared, over the function itself, 2x cubed minus 1. If we do some simplifying here, I'd get 1 over x plus 4x over x squared plus 1. And over here, the 2 would cancel the 6 and give me a 3. So it'd be minus 3x squared over 2x cubed minus 1. And it seems like that was a much simpler way to do that derivative. Expand your logarithms first. It's going to make your derivatives a lot easier. Now, sometimes, don't let it fool you. If there is an absolute values on the inside, it doesn't matter. It's just taking advantage of the fact that you can't have a negative number inside the logarithm, so it's putting absolute values there to say, hey, whatever function's there, I can take the natural log of any value. The derivative is still going to be the same. It's still going to be u prime over u. So notice the absolute values here. They're kind of hard to see. What is the derivative of the natural log of cosine? You would take the derivative of the inside function over the inside function. Oh, wait a minute. That reduces to the negative tangent of x. There's my derivative. Oh my goodness, we're throwing in trig with logarithms. Now the next problem, I tell you what, I am going to expand that logarithm first. I'm not going to take the derivative yet. I'm going to bring that 3 out front. And it would still work out. It would be 3 times the derivative of the natural log, which would be 1 over x. So this would be 3 over x. Hey, wait a minute. I have another idea here. What if I took the derivative of the natural log of x to the 4th? Well, I could bring the 4 out front. And the derivative of the natural log would be 1 over x. I'm wondering, what would the derivative be of the natural log of x to the n? Well, I could bring the n out front, and the derivative of the natural log would be 1 over x. So there's another little formula we can use for logarithms that's going to make life a little easier. Maybe you can pause the video and write that down. Now, when we've done derivatives, if you've watched my past videos, you know when we take derivatives, one of the things we like to do is we like to do tangent lines. How would you write the equation of the tangent line to this function below at the point e, comma, e to the 4th? Okay. If I take the derivative of this function, I'm going to have to use a product rule. The derivative of the first part would be 4x cubed times the natural log of x plus x to the 4th times 1 over x. So the derivative here is actually 4x cubed natural log of x plus x cubed. Now, how do you find the slope of a tangent line? To find the slope of a tangent line, we'd have to do f prime at e. which would be 4e cubed natural log of e plus e cubed. But wait a minute, the natural log of e, what does that equal? That's 1. So this would be 4e cubed plus e cubed. The derivative is 5e cubed at that coordinate. And how do I write the equation of my tangent line? Remember, we do y minus y sub 1 equals m times x minus x sub 1. I just think point slope is easier than all the rest because I'm given a point and now I have a slope. So it'd be y minus e to the fourth equals my slope, which is 5e cubed times x minus e. Now, AP exam, they'd accept that answer. If you really have to solve for y, this would give me 5e cubed times x. This would be 5e to the fourth minus 5e to the fourth. And then I'd have to add the e to the fourth from the other side. So if I want to put this in slope-intercept form, it would be 5e cubed x minus 4e to the fourth. So that would be my slope-intercept form. Hope this video helps you. If my videos have been helping you, please like the video and maybe subscribe to my channel. I'll be posting more videos later.